Welcome to Session 5, Multi-Step and Compound Inequalities. This lesson strengthens algebra that remains reliable when the numbers or representations become unfamiliar. You will learn to solve multi-step and compound inequalities accurately, to reverse the comparison only after multiplying or dividing by a negative, and to represent endpoints and solution direction consistently. Treat these as connected habits. Keep a pencil ready. We will build a visual model, use a repeatable process, solve a demanding example, diagnose an error, and finish with a checkpoint. Start with this picture. Endpoint style records inclusion, while ray direction records all satisfying values. Read boundary and direction separately. An open point excludes the boundary, a closed point includes it, and the shaded direction should contain a test value satisfying the original inequality. The key distinction is this: solve multi-step and compound inequalities accurately. Then connect it to the second goal. Reverse the comparison only after multiplying or dividing by a negative. Correct methods begin with correct interpretation. When a problem looks different, look for the same mathematical structure instead of an identical example. That transfer makes the skill durable. Step 1. Simplify both sides exactly as for an equation. Identify the object being changed and the requested result. Step 2. Isolate the variable while tracking the sign of every divisor. Use a separate line so signs, units, and restrictions stay visible. Step 3. Flip the comparison only when multiplying or dividing by a negative. Work efficiently without skipping an operation. Step 4. Test one interior value and, when included, the endpoint. Whenever possible, verify with evidence independent of the original working. Signal 1 is negative variable coefficient. Respond by remembering. Expect a sign reversal during final division. Name the response before calculating. Signal 2 is 3 minus part comparison. In that case, apply each operation to all three parts. The form tells you which tool fits. Signal 3 is strict symbol. Remember, use an open boundary point. This separates plausible from valid answers. If you cannot name the signal, slow down. Deliberate classification is faster than repairing rushed algebra. Here is the challenge. Solve 2 minus 3, 2x minus 1, less than or equal to 5x plus 9. Restate the target and identify the most important part of the routine. The first move is distribute. 2 minus 6x plus 3 less than or equal to 5x plus 9, so 5 minus 6x less than or equal to 5x plus 9. This changes the form without changing the meaning. Next, subtract 5x. 5 minus 11x less than or equal to 9. Keep the relationship visible and apply the operation to every required term. Now audit distribution, signs, copied values, and restrictions. A brief midpoint check is cheaper than rebuilding the solution. Continue with the third step. Subtract 5, 11x less than or equal to 4. State what the transformed line tells you. Complete the argument. Divide by minus 11 and reverse. X greater than or equal to 411. This is a part of the solution, not decoration. The final answer is x greater than or equal to 411. Compare it with the requested variable, expression, unit, interval, or classification. Verify from another direction, substitute, compare representations, inspect units, or test a boundary. Prove that the result satisfies the original conditions. Try this checkpoint without copying the example. Solve 4x is greater than 12. Decide which mathematical fact controls the answer. Write one line of reasoning before you commit. A visible decision is easier to inspect and correct. A focused hint. Dividing by minus 4 reverses the inequality. Use it to repair your setup rather than guess. An accepted answer is x is less than minus 3. Explain why it works and name the first step that would expose a common error. The central message is solve multi-step and compound inequalities accurately. Combine it with a discipline to reverse the comparison only after multiplying or dividing by a negative. Finish by remembering to represent endpoints and solution direction consistently. This turns a calculated result into a justified answer. Reflection. What test value would quickly confirm the direction of your solution ray? Name the error specifically so you can interrupt it next time. Practice one fresh problem within 4 minutes, including a test value. Keep the work readable, check it independently, and carry the routine forward.